All right, welcome to The Explainer. Today, we are getting into a feeling that every single endurance athlete knows all too well. Why do some workouts feel like you're just floating, while others feel like you've slammed into a brick wall? We're going to break down the science of exactly what's happening inside your body. So picture this. You're in the middle of a tough set of hill repeats or a hard progression run. The first few minutes, you feel great, right? But then, as the pace really gets serious, you can feel your engine screaming for more fuel, like right now. What is going on there? Well, that feeling, that's your body's metabolism making a really critical decision in real time. It's switching its primary fuel source. The best way to think about this is to imagine your body is like a high-performance hybrid car. It's got different modes for different situations. At those low sustainable efforts, you're just humming along in this super efficient electric mode, cruising along mostly by burning fat. But when you put the pedal to the metal for a really hard push, the whole system switches over to gas mode, burning through carbohydrates for maximum power. It's a pace that's incredibly powerful, but it's ultimately unsustainable without refueling. Okay, so what's the actual science behind this switch? Going from that efficient fat burning to this high-octane carb burning. Well, it's all explained by a fundamental principle in exercise physiology. It's called the crossover concept. And honestly, it's pretty straightforward. All it says is that as your exercise intensity goes up, your body progressively shifts from using fat as its main fuel to relying almost entirely on carbohydrates. And this isn't just some theory. It is the core model for understanding how your body powers your workouts. And this chart right here, it shows you exactly what's happening. Look over on the left. At a low intensity, maybe 25% of your max effort, you can see fat use is way up and carb use is low. Now, as you move over to a more moderate intensity, they start to even out, right? But look what happens when you get to high intensity, say 85% of your max. Your reliance on carbs just skyrockets, while fat use practically falls off a cliff. Now, here's where it gets really interesting. For a lot of trained athletes, there's a sweet spot, a point where you burn the absolute maximum amount of fat. It's often called fat max, and it happens right around 55 to 72% of your VO2 max, which is basically your aerobic ceiling. For most of us, that's going to feel like a steady mid-zone 2 effort. But the second you push past about 85% of your max effort, we're talking high zone 4 or into zone 5, bam, the crossover is complete. Carbohydrates become the undisputed king, providing nearly all the energy your muscles are screaming for to produce that top-end speed and power. So, the million-dollar question is, why? Why does your body make this switch? Why can't that super efficient fat-burning engine keep up when the pace gets truly serious? Well, it all comes down to one thing: the need for speed. See, there are three key bottlenecks that just hold fat back. First, fatty acids are released pretty slowly from your fat stores. Second, actually getting them transported into the muscle cells is a slow process. And finally, the actual chemical reaction to turn fat into usable energy, or ATP, is just fundamentally slower than doing the same thing with carbs. And this quote from the research really just nails it. Carbs don't just produce energy faster, they're also more efficient when it comes to oxygen. And think about it, when you are breathing hard and totally pushing your limits, getting more bang for your buck from every single breath you take is absolutely critical. Okay, so that's the what and the why. Now for the really important part. How do we turn all this science into practical strategies that you can actually use on your next workout or in your next race? And honestly, the strategy is pretty clear when you look at it this way. For those low-intensity Zone 2 sessions, where your goal might be to improve fat burning, you might need minimal or even no carbs. But for your high-intensity threshold or VO2 max workouts, maximizing your performance absolutely requires a high-carb intake, often somewhere in the range of 60 to over 90 grams per hour. So the tactics become pretty clear. First, you've got to protect your limited onboard carb stores, your glycogen, by fueling properly during your exercise. This saves that precious fuel for when you really need to push. Second, pace yourself sensibly. Don't go flying out of the gates in a long race and burn through all your glycogen too early. And third, and this is a big one, you need to train the gut. Just like your legs, your digestive system can adapt to handle more fuel during exercise, which is so crucial for avoiding those dreaded GI issues on race day. But let's be real for a second. For a lot of athletes, trying to force down 60, 70, even 90 grams of carbs an hour can be a huge challenge for the gut. Sometimes your digestive system itself becomes the limiting factor, the real bottleneck in how much energy you can get to your muscles. And this is where some targeted support can really play a role.
So the source material we're looking at highlights how a product like Carb Accelerator is actually designed with this physiology in mind. The whole idea is to use enzymes like amylase, which help pre-digest carbohydrates, and combine them with botanicals like ginger and peppermint that are known to help with GI comfort. The goal is simple: help athletes better tolerate the high-carb intake that high performance demands.
So, after all this science and all this strategy, what is the single most important thing to take away from this explainer? If you're going to remember just one thing, what should it be? It is this: match your fuel to your intensity. It's really that simple. Don't underfuel your hard days, and you probably don't need to overfuel your easy ones. Understanding what your body needs based on the demands you're placing on it, well, that's the simplest and most powerful performance strategy you can use. Remember, you're a hybrid engine, so use the right fuel at the right time. And that brings us to the final question I want to leave you with. Now that you're armed with this understanding of the crossover concept, how are you going to approach fueling your next race, your next hard workout, or that next decisive moment when performance really, truly counts?